everyone. This is Dr. Paramita Chakraborty. I'm an associate professor in the Department of Civil Engineering and SRM Research Institute in SRM Institute of Science and Technology, Kattankulattur, Tamil Nadu. Learners, in the previous module on water quality, you learned about the inorganic pollutants present in freshwater resources. I'm sure by now you are aware of various pollutants potentially present in water bodies around you or in the source of your drinking water. However, what you learned about the pollutants is just one side of the coin. There is much more to learn about another group of pollutants, which is organic pollutants present in freshwater. Precisely, these are microorganic pollutants. Organic pollutants can be both naturally occurring and synthesized compounds and can pollute agro-ecosystem either deliberately through crop management activities or accidentally through entry of industrial or urban wastes. Organic contamination indicates the secondary and tertiary dispersion of organic compounds from various sources into the global circulation across Earth system components mediated primarily by the human activities. In the recent years, the ubiquitous presence of organic pollutants, especially in wastewater, have raised serious concern in the scientific community due to their severe damage to the aquatic ecosystems. These are a wide array of organic contaminants, including dyes, humic substances, phenolic compounds, petroleum products, surfactants, pesticides, plasticizers, and pharmaceuticals. Such pollutants pose a significant threat to the freshwater ecosystems, which play a pivotal role in supplying drinking water, maintaining regional ecological balance, and supporting socio-economic development. Further, presence of such pollutants in water is a critical concern because of their toxicity, semi-volatile nature, low water solubility, bioaccumulation capabilities, and non-biodegradability under normal environmental conditions. Among the various organic pollutants of utmost importance is the class known as microorganic pollutants, which are known to cause endocrine disruption and are also carcinogenic in nature, even at micro levels. These compounds include persistent organic pollutants such as polychlorinated dibenzopyridioxins, polychlorinated dibenzofurans, polychlorinated biphenyls, and organochlorine pesticides such as DDT, hexachlorocyclohexane, chlordin, and hexachlorocyclobenzene. POPs are mostly anthropogenic chemicals that are semi-volatile, persistent, and able to undergo long-range atmospheric transport. POPs are lipophilic, which means they accumulate in the fatty tissue of living organisms and as well as human beings. In fatty tissue, the concentrations can become magnified by up to 70,000 times higher than the background levels. As you move up in the food chain, the concentrations of POPs tend to increase so that animals at the top of the food chain, such as fish, predatory birds, mammals, and humans, tend to have the greatest concentrations of these chemicals and therefore are also at the highest risk from acute and chronic impact of these contaminants. Due to their bioaccumulative, biomagnification, and toxicity, POPs have become an impending threat for the ecosystem. Global concern driven by their persistence and toxicity forced around 90 countries to sign a groundbreaking United Nations treaty exit in Stockholm, Sweden in May 2001. Under the treaty, known as the Stockholm Convention, countries agreed to reduce or eliminate the production, use, and or release of 12 key POPs known as the Dirty Dozen, including intentionally and non-intentionally produced compounds. Now, let us learn about the sources of the organic pollutants. Sources of POPs or other organic pollutants include improper use or disposal of agrochemicals, industrial chemicals, elevated temperatures and combustion processes, unwanted byproducts of industrial processes or combustion. Precisely, POPs are of two kinds: intentionally released POPs, including PCBs, organochlorine pesticides, and unintentionally released POPs including dioxins and furans. Sources for intentionally released POPs such as PCBs include release via volatilization from landfills containing transformer, capacitor and other PCB containing wastes, shipbreaking activities, sewage sludge, spills and dredge spoils and improper or illegal disposal in open areas. Pollution may occur during the incineration of industrial and municipal waste as most municipal incinerators are not effective in destroying PCBs. Further, common waste reducing activities, especially in the developing nations, such as open burning of dumped waste, has been evidence to release elevated amount of PCBs. In addition, rudimentary processes practiced in the informal e-waste recycling workshops, such as burning of plastics, acid leaching, to obtain the underlying precious metals, have been found to be an important emission source of PCBs in India. Organochlorine pesticides, on the other hand, can be released via volatilization from pesticide-laden agricultural soil, usage for vector control in developing nations, surface runoff from agricultural lands, wastewater discharge, and re-emission from soil or sediment. It is interesting to note that apart from POPs, there are several other endocrine disrupting compounds that are not persistent in nature. However, due to their pervasive usage and continuous influx in the environment, they are termed as pseudo-persistent compounds. These compounds include industrial chemicals such as plasticizers, for example phthalic acid esters, additives, for example bisphenols, and unintentionally produced pollutants such as polycyclic aromatic hydrocarbons. Wastewater discharge and surface runoff have been consistently termed as the primary sources for these compounds in the aquatic system. Secondary sources in the aqueous system might include open burning of waste and plastic waste, or waste sludge discarded by the industrial or informal e-waste recycling sector, or shipbreaking activities, which can come via surface runoff. The background levels of these contaminants in the natural environment are negligible. However, many exist in the environment in sometimes as small as picogram levels. Therefore, detection and quantification of these classes of pollutants becomes a tedious and expensive job. Although in the past, liquid-liquid extraction using separating funnel was employed for the extraction of POPs and other microorganic pollutants from water and wastewater. But recent techniques using solid phase extraction vacuum unit has been found to yield required recovery percentage and pass the strict quality assurance and quality control protocols. However, quantification of organic pollutants is expensive and it requires extremely sensitive instruments to detect and quantify compounds in micro levels or sometimes even in nano levels. Depending on the vapor pressure or volatility of the compound, suitable instrument is chosen. For example, for volatile or semi-volatile compounds, gas chromatography is used, while for more hydrophilic compounds, liquid chromatography is used. It should be noted that unintentionally released POPs such as dioxins and furans are present in sometimes as low as picogram level or even in nanogram level. Hence, for such compounds, high resolution gas chromatography, high resolution mass spectrometry is used. Quantification of organic pollutants, precisely microorganic pollutants, in different environmental matrices require highly sensitive instruments because these contaminants are present in very low levels, up to parts per billion or even lower.